Very good morning to all. Today we have one very important topic related with moisture meter. Actually, we are all related with alcohol measurement in the society, because we are actually government of India is going to implement the new provisions for the breath analyzers. So how to test them, how to verify these breath analyzers, these are very important. We have with us Professor Dr. Prabha Jory, who is a retired scientist from the National Physical Laboratory. She has done a lot of work in this field, and she has actually developed the CRM and all for the testing of these breath analyzers. Thank you very much, ma'am, for accepting our request. She has done a lot of research work, R&D work, research papers, everything. I actually, whatsoever she has done, I'm not in a position to say. It will be just to show a lamp to the sun. Thank you very much, ma'am, for accepting our request. We have with us our Honorable Dikshit sir, Shri B. N. Dikshit, Director Legal Matters, sir. Sir, would you like to speak 2 words, please?
Ji.
Sir, very good morning.
A very good morning, Astosh ji.
Thank you, sir. Very good morning, sir. Over to you, sir, please.
Dr. Johari Madam, today chief guest of the program. So very good topic on the breath analyzers regarding the measurement of alcoholic measurement in the present society and its standard measurement. The standard measurement has been developed by the BIS as well as the NPL. So they are the expert on this subject, and Dr. Johari Madam will speak that how to best uses of this and what are the important, what are the scientific significant of this. Breath analyzers play the very important role for the measurement of this alcohols and other things by the various police officer during the different crimes, as well as by the doctors when these peoples are being cast and they are taken to the hospital to verify that whether the whatever their alcohol measure they have taken, it is within the limit or beyond the limit, to make the case of road accident and all those very things. So that point of view, the breath analyzer is very important for the measurement of the alcohol. So this way, this is the very different topic, and I hope that Dr. Prabha Johari will speak on this very issue, and she will enlighten us as well as the scientists and industry people who are taking participation in these very programs, and the scientists and the legal methodology officers who are joining this very program. All will be benefited. So this is the things. Over to you, Astoshi, to request Dr. Johari to speak on this issue.
Thank you, sir. Thank you very much, sir, for a kind and motivating words. Always. Thank you very much, sir. Thank you. Sir, we have Dr. Prabha Jory, who is actually the head, who was the head and scientist of Gas Metrology Society, Gas Metrology Activity of CSIR NPL. She has done a lot of work. I know her since last many years, and actually we were thinking how we can develop this testing facility in our RRSS. So, sir, I hope with the help of Dr. Johari, we will be in a position to develop this facility in our RRSS as well as with the state governments. With your permission, sir, I would like to request Professor Johari to kindly take over and simply let us know what is this technology, how we can utilize this technology, and how we can actually calibrate, verify, and test these breath analyzers. Over to you, ma'am.
Thank you,
Thank you, ma'am.
Dixit sir. Thank you, Asutosh sir, for giving me opportunity to share my experiences for that. First of all, my namaste and good morning to all the participants, and I'm thankful to them that they are here to listen to me. And together I can also learn, because this subject is very near to my heart, and I wish to know more what kind of things are going on in my country. I don't have much knowledge that but scientific facts I know. So I will share my experience, and I will get enriched from you all's experience. So can we proceed ahead? Sir, am I eligible? Am
Yes,
I visible and audible clearly?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Very well. Kindly, ma'am. Kindly. Please, over to you, ma'am. Thank you. And with your permission, ma'am, we will put this video as well as the presentation in all public domains on our YouTube channel. Everything will be available in the public domain after this program, ma'am.
Okay.
Thank you very much, ma'am. Over to you, ma'am. Thank you.
Okay. Thank you. Namaste. Good morning. Today I will be talking about the importance of alcohol measurement in present society and its standard development. Of course, I will be focusing there is need for the alcohol measurement in many areas, but I will focus but overall picture we will look into that what are those reasons. So the key highlight of this lecture will be need of alcohol measurement for various purposes, measurement techniques for alcohol measurement, breath alcohol analyzer measurements, and its unit BRAC and BAC. Chemistry behind its working, because we are scientific and metrology community, so always try to understand on which principle it works and what are the nitty-gritty of mechanism of it. Again, mechanisms of various types of breath alcohol, there are plenty of them are available in market. So which is based on what principle and how much reliable it could be. As sir was mentioning about the type certification, as our legal requirement also mentions that. So we will just look into a little bit. And after that, I will tell preparation of aqueous calibration standard, how it could be done, preparation of gas mixtures, how it could be done, then how the traceability, because nowadays many people get caught and then that contest it in court. So we have to be, measurement has to be traceable, it should be worldwide accepted, then only, and pros and cons of both the types of CRMs, like aqueous is available and gaseous is available. Which one one should go with the pros and both having that. Then concluding remarks about it. So this will cover my lecture's topic. So alcohol as C2H5OH in chemical formula is there. So the oldest mention of alcohol in India are found in our Vedas, specifically Rig Veda. This indicates that alcohol consumption, particularly in ritualistic context, was prevalent in ancient society. So it is not that present society. Since the advent of, I will say, human civilization, it has been in use. Similarly, for the India, this is archaeological evidence suggests that people in Neolithic China were making alcoholic drinks by fermenting rice, millets, grapes, and honey around 7000 BC. So it was prevalent in society. Why it has become more relevant today, more relevant, because in ancient time we were not doing, after consumption, we were not very highly skilled technical work. where my life and the other people's life, if I am you after doing, will be at risk. So it was not that much challenging. But nowadays, it is much and more challenging. If you are consuming alcohol, then you are not supposed to do very, very specific technological work where you need to be 100% alert. You should have 100% alert of body control. Very good. All the people of our generation will recall, we all have grown up hearing two very powerful statements by the, what I should say, delivered by the Sadiq Mahanayak. Hamare great actor has delivered. I will not repeat those things. So there, those two statements about alcohol is very, very important and gives the barometer and requirement of society. So of course, a younger generation may not know one of them. So if you want, you can say here on the internet. So with that reference and my support, many times people tell it is good for health, good or bad. I am not going into that. But of course, I underline a statement by WHO, which states that the World Health Organization states that there is no safe limit of alcohol consumption when it comes to health, that alcohol is known carcinogen. WHO emphasizes that even low level of alcohol consumption can increase the risk of certain health problems. So we should be careful about it. I'm not telling one should not drink or not drink, but be careful. And even if you are drinking, you should be responsible drinker. You should be responsible. You should not harm your health, and you should not be danger to others. With these words, we move ahead. So what are the places where we need to know that need of alcohol measurements are required? So first is alcohol as a drink, for example, beer, wine, whiskey, cider, vodka, as chemicals, drugs manufacturing. Here the concentration of alcohol we want to know, 5%, or you can say 0% to 100%. For the chemicals, we want to know the purity, how much pure is. Suppose if you want to make it used for medicines or some other purposes, then you have to do this. So measurement ranges varies depending upon needs. Which area, what is your requirement, then and then methodology also there. Like alcohol in food items such as fruit, juice, ice cream, cakes, jams, and all. Here the concentration range is 0 to 2%. If you go for fine dining in any of very refined places, then you will find that some of the preparations are done putting alcohol in that, very nice presentation, fire coming, you may enjoy that moment and all. But research shows, as the chefs claim, that alcohol is burned away, but research shows that some amount of alcohol is remaining. So if somebody is confused, sometimes you may, like in ice cream and cakes or jams, then you need to know. You need to know for the proper labeling of that, and you need to know that for collection of taxes also important, because nowadays a lot many food items are made by adding alcohol for some formulations, and then semi-cooked or cooked, preserved, ready-to-eat foods. So there also you need to know, and that is in their food matrix, different food matrix, right from meat to bread or cake or that kind of. So such kind of measurement requirements are here, there also. Then comes the consumption of alcohol. A lot many people drink alcohol. Then you need to know the alcohol. Then you need to know the alcohol concentration. for the aviation personnel. Somebody who is in the aviation industry needs to know before he goes for the flight and flies a plane, or air hostesses and on drink and driven cases. Now, in the case of court cases, divorce, child custody, then also you need to know what is the concern, because many a times partners blame to each other that my partner is drunk and he causes or she causes trouble to me. Then custody of child. So whom to be given? Then in that case, court tells to monitor the alcohol in their blood. So in that case, the blood alcohol is measured in breath, blood, and urine. These are the three options. Now, when we will go detail into it, we will learn which cases, whatever there. Then there is a forensic need of measurement. Road accidents, insurance settlements. In that case, blood, urine, kidney, and some other tissue of the body. Suppose an accident has happened. Now, insurance company claims that that accident has happened because the person was drunk. Now, in order to prove that whether the person was drunk or whether the accident has happened due to other person's mistake, or sometimes due to faulty road or some other thing, in that case also we need to know what is the concentration of alcohol in the body. Sometimes some people may die, that situation also. So all these things are required in the. We will go one by one. What are those areas where I was talking about, where in percent, several methods are used to determine alcohol content for ensuring accurate alcohol content. Labeling for beverages, there it is used. Density measurement, digital density meters are there. For beverages, the density of the liquid can be measured and then converted to alcohol content using established. A table is there prepared for different concentration and ranges and calibrated, so that once you tip that density meter, nowadays digital density meters are coming, so and it gives you how much percentage of value it is coming with the greater precision and efficiency. Then hydrometer, refractometers are there. These tools are used to measure a specific gravity of liquids, which can then be used to estimate alcohol content, especially in home brewing. So many people prepare the alcohol at home. That is in their culture. In our country also, Goa and some regions people do. Of course, in our plain, this reason I don't think people would be doing. Or maybe I am not having much idea about it. Next is infrared or middle infrared spectrum. These techniques are used for a specific application, such as wine beer analysis, big factories, rapid or accurate measurement. Sometimes for this is used for the drug applications also. Suppose you want a very pure alcohol for some drug preparation, medicine preparation, because it's a very good solvent. It is used for many other mid preparation of many drugs and chemicals, life-saving drugs. So that is where this are used. Steam distillation. This method involves distilling a sample of beverage and measuring the alcohol content of distillate for the purification purpose for the very ultra high pure chemicals. So distillation and chromatography for high purity chemicals and as a drug reagent. Conventional chemical methods are also used, like titrimetry and all methods to colorimetry to determine. These tools or these methods are used where from one can say 0% or 1% to pure either alcohol or alcohol in miscible water or some other like grape, any alcohol preparation from grapes or these kind of things. These methods are used. Then comes what we are focusing in this presentation. We need to know the content of alcohol for following very urgent need. This affects each one of it. Anybody who drinks or even he or she doesn't drink. Because you go on road, you may get a fatal accident, then blame will come to you, that whether you were drunk or the other person was drunk. So blood alcohol for the people working in aviation industry, drink and driven road transport, relationships in court cases, divorce and child custody. So concentration ranges here, which is measured as blood alcohol content, it is 0 to 1.5% of blood alcohol. Usually the measurement is done in breath, blood or urine. Forensic need of measurements are further, as I discussed previously, road accidents, insurance settlement, blood, urine, kidney, or maybe any other body tissue where you have to measure. Now, in our country, for the drink and driven case, the Motors Vehicle Act 1988. It was amended, the bill was laid, I think, in 2016, I think. Amendment has been done and government has made the rules very stricter, and the limit is, in the blood alcohol is 30 mg per 100 ml of blood or 300 mg per 1 liter of blood of anything. Here, if you read this law, this bill, then you will find the limits have been very, very strictly, this limit is very, very strict limit. And if somebody is found to have the blood alcohol in the screening by the police can arrest the person without a warrant. If he or police has a doubt whether he or she can be arrested without warrant. And if he has a more doubt in the blood alcohol, suppose in the screening, and he wants to, he has to take you to a medical center approved by government, where from the blood they can take the blood from you and confirm that whether are you really. If anyone refuses that to give the blood, then he is supposed to be guilty of the crime. So one has to be very careful about these things, where license can be cancelled, he can be jailed, and 10,000 or some amount, I don't remember, I read. So these are very severe. But okay, rules are very severe, but as a citizen of this country, we have to be also responsible. We should not put our life and other people's life at the risk. That is, we have to understand. So respect the rule. That is what I feel and tell. Even they can arrest, they can take you to anywhere and do that. Now, just let us have a look at that. What is the limit of alcohol drink in the drink and driven in the various few countries I have listed. So I was surprised very much that UAE, Ukraine, and Slovakia, Sudan, and Yemen have zero tolerance. Very, very, I was surprised. This country have maintained the zero. China and Sweden has 20 milligram of alcohol in 100 ml of blood, the unit generally being talked. India has 30 mg per 100. Australia, Scotland, Denmark, France, Germany, and Switzerland 50. Canada, Singapore, USA, UK, all these have very higher limits. I was surprised. This is very high. And the age to drink alcohol also was varying in our country. It ranges from 18 to 25. So one has to be someone one young boy is drinking, it may be crime in one state, it may not be crime in one state, it may become crime to others. So people should be aware, especially the young generation should be made aware that if you are consuming alcohol at a place where what is the limit of it, one should not do wrong, should follow the rules. So they must respect it. So there is no unanimity in India also for the drinking. For other countries, I have not collected it, and I found it is very, very low, up to I think 10 or 12 to not very, for many countries it was very, very low. So I thought, oh no, but in our country from 18 to 25 years, many states has 18 I think Delhi has 25. If I'm wrong, then I don't remember, but this is something. Now let us have a view. Let us see what are those countries who consume highest amount of alcohol. The top 5 highest alcohol consumption country in the world. So here the unit is per person per year. All the people, they have accounted for this data has been taken from that WHO data. World population data, I'm sorry. So alcohol person 50 above 15 year age. So Romania, Georgia, Latvia, Lithuania, Czechia, and Germany is the fifth. India's is very low. And I'm happy that India has a less amount of that 4.1 liter per year per person. This is the limit and consumption. So just to have the feeling that how much people are. So now breath analysis. We come to, if we wish to measure the alcohol in the any one person, whether he has consumed it or not, then we need to measure it. We measure it by using breathalyzer. Breathalyzer, also called an alcohol meter, is a device for measuring breath alcohol content. BRAC. So how much is alcohol content in the breath? This instrument was invented by Robert Frank Borkenstein, who is also responsible for the invention of lie detector. Very important point. So it was invented, an American inventor, researcher, and anthropologist. He is best known for inventing breath analyzer. It is a device that is used to detect person's alcohol content from their breath. Initially, it was invented for the purpose of monitoring of wives, whether their husbands are drunk or have taken alcohol or not. Very interesting to me. But now it is being used for various other purposes. Some of the novel uses of this instrument is there. There are variety of mechanisms used for breath analyzer. For example, oxidation or with potassium permanganate or infrared spectroscopy or fuel cell based. So here it is a device. Here is an inlet. You have to deep breathe into it, and the result will be displayed over here. How the mechanism it will work, that we will see into it. How breath analyzer detects alcohol in the breath. The basic chemistry of an electrochemical electrolyzer is as user exhales into the breath analyzer, ethanol present in the breath is reacting with the is oxidized to acetic acid after with the water moisture present in it. So acetic acid is converted, and an electron is, this electron goes to at the cathode, it oxidizes, it is absorbed, this electron is captured by oxygen and the proton ion and converts to water again. So whatever water has been consumed here in the conversion of acetic acid has been consumed, regenerated here. The overall reaction in the oxidation of ethanol to acetic acid and water is as the electric current generated in this is measured. The electric current produced in this reaction measured by microcontrollers and displayed as an approximation of overall blood alcohol content by the sensors, or maybe some other detector technique, whichever you follow. So many of them are, we will discuss about these things. A very small amount of alcohol is found in human breath. Only air in the deepest portion of lungs, known as alveolar sac, comes into contact with alcohol. If present in the blood, there is an equilibrium between alcohol in the exhaled air and alcohol in the blood. This process of equilibrium of alcohol between alveolar air and blood is based on Henry principle, which states that the ratio between alcohol in blood and alcohol in deep lung air is constant. What Henry law states? Henry law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas above the liquid when the temperature is constant. So now you can understand how much is the alcohol in the blood. That amount will be proportional to the partial pressure of gas present in the, so whatever you breathe, that will be the, so Henry law dictates that the concentration of alcohol in alveolar air directly proportional to the partial pressure of alcohol in the blood. Breathalyzer measures the concentration of alcohol in the breath sample, which is assumed to be in equilibrium with the alcohol in the blood. This ratio typically ranges from 2000 to 1:1 ratio to 2300 to 1:2 ratio. This ratio depends on the body structure and so many, what I should say, physiological parameter of the person. So widely it has been accepted, maybe country to country, people to people, like some where people may be more, or some places people. So it has been accepted that 2100:1 ratio will be used for the calculation of the BAC or breath alcohol content. So this is not just a one number constant, but it ranges from, and it needs a physiological study to know what is the exact value, but moreover, less widely it is accepted that 2100:1 ratio. Now converting whatever concentration we measure using analyzer, that is BRAC, the BRAC. Now, from that, using that constant, you have to convert it to BAC. The breath analyzer first measures BRAC content in the breath sample. The breath tester must then calculate how much ethanol measured from the expired air sample is in the blood. To do this, the formula takes into account of the volume of blood from which the ethanol originated. To convert BR to BRAC, breath analyzer uses a ratio that we have shown on the blood concentration that evaporates and is expelled in the lung. This ratio means that every 2100 ml of air in the breath will have the same alcohol content as 1 ml of blood in the body. Once the processor in the breath analyzer makes the conversion, BAC level is expressed as gram per 100 ml of blood, or that is percent of BAC. BAC versus BRAC. Both BRAC and BAC are unit of measurement used to calculate the amount of alcohol present in one system. The difference is that BAC results are typically obtained by taking blood sample, whereas BRAC results are obtained through the breath sample and through the breath analyzer. However, as we have learned above, BAC readings can be converted to BRAC reading using the ratio of what we have shown you, 2100:1. Below are the typical way in which BAC or BRAC can be expressed. BAC units of measurement, BAC results are typically expressed as mass of alcohol per volume or mass of blood. Both ways it can be expressed. Percentage gram of alcohol in 100 milliliters of blood, or milligrams of alcohol in 100 milliliters of blood. Promille is also one unit which is in use in so many countries. So gram of alcohol in 1 liter of blood. If we express in terms of gram of alcohol per 1 liter of blood, then it is called promille at place. You can write down gram per liter also, or either you can write promille. The relationship between these expressions is illustrated as follows. 50 gram of mg per percent as BAC unit is equal to 0.5% BAC and 0.5% promille. Okay. now we will move to the one type of electrochemical fuel cell breath analyzer, how it works. So electrochemical fuel cell analyzers are device in which electrical current, basic chemistry we have seen it. So that chemistry, how it works on it, there is a platinum electrode over there, and inside it is a medium through which electron can pass through. So alcohol is converted to acetone, acetic acid, protons are this, and electrons are there. Here it is oxygen, and so it is transporting across it, and the current which is flowing, this whole system is inside this system, and it has a display system. So on the display, you get how much current has been produced, and that is converted into concentration. So electrochemical fuel cell breath analyzers are devices in which electrical current is produced as a result of chemical reaction taking place on the surface of electrode, as I have showed you. The chemical reaction that takes place converts any alcohol into acetic acid. This conversion produces a mixed number of electrons per molecule of alcohol, and this smaller electrical current produced by the alcohol in a person's breath reacting on the electrode gives within the machine can be used to give a digital display through the processor and move a needle or trigger certain lights on the device, and depending on the amount of alcohol detected. So this is one type of electrochemical fuel cell. There are plenty of them. Two important of them. The fuel cell technology is particularly suitable for portable screening device due to small size of cells and the lower power requirement of the tank. The majority of handheld screening device used by law enforcement officers use electrochemical fuel cell technology. Fuel cell breath analyzers provide accurate results but are quite expensive to manufacture because that has to be very stable and the electronics has to be. These are known to be more accurate than the semiconductor counterpart for their ability, because semiconductor kind of the analyzer becomes contaminated very fast. So it loses its sensitivity and linearity. The ability to only measure ethanol, but the compound that is present in alcohol for better result. The fuel cell breath analyzers are also able to measure breath alcohol up to 3 decimal places, making them the undeniably a better choice. So because here stability is good, repeatable results comes. Another type of here we will be discussing about that infrared breath analyzer. Infrared breath analyzer, this type of breath analyzer allows a high degree of specificity for ethanol. Typically, evidential breath alcohol instruments works on the principle of infrared spectroscopy. I have found that from the internet, what kind of analyzers our police uses in our country, we don't know. But I found in USA from the internet information, and UK police mostly uses this type of analyzer for their monitoring and conviction kind of purposes. So here it is a quartz lamp, a beam of infrared light is put on, lamp lenses are to filter it, and breath is passed into it, and breath goes out of it, and filter will detector detects when a pulse microprocessor detects when the light is shown at it and how intense it is, and with that signal is converted to the value after calibration, that for this much amount of alcohol, this much signal is coming, and then that is put into display. So a display system will be there inside the instrument, all this kind of arrangement, and one can do here. The infrared analysis is a non-destructive technology, and calibration of instruments shows very good long-term stability. The theory and practice of infrared spectrometry is well established and is widely used in analytical chemistry for identifying functional group. So this is very, very reliable in organic compound. Infrared spectrometry applied to breath alcohol analyzer monitors the absorption of selected wavelength of infrared radiation after passage through a known volume of breath sample. The higher the concentration of ethanol in the sample, the more infrared energy is absorbed, and lower is the percent transmittance. Here 1.1 we have to it measure, okay, that point I will highlight here. The alcohol have characteristic IR absorption associated with OH, CO, CH bond, stretching vibrations. So CH bond vibrations are not unique for alcohol. So many other organic molecules have such as, but in the breath, other molecules will not be, so it functions in a better way, such as hydrocarbons, acetones, also have CH bonds that can absorb higher radiation and at the 3.3 to 3.5 micrometer wavelength. Since in human breath, no such compound is present in it, so it gives reliable result. Infrared absorption spectrum of ethanol is shown here in the figure given below, just at the frequency level. But sometimes it becomes dubious because if a person is diabetic, severe diabetic, then that person breath may contain keto. So then in that case, it becomes a little bit dubious. So that one has to take. Otherwise, in general case, it is very, very good technology and technique, and it is used by many of the developed country police. I have no idea that what kind of instrument is used in our country. Thank you. Besides these two measure type, many of the other types of analyzers are some disposable type of breath analyzers are available. Disposable breath analyzers are ideal for quick screening at the workplaces or corporate events. They are also good choice for drivers who occasionally need to check themselves. If they consume, then they if they consume alcohol, at least people should be responsible. If they are responsible, they check themselves. So it is at low price, simple operation, fuel cell or semiconductor. They work via a simple chemical reaction. Air is blown in the balloon and this connects to the tube filled with the granules. After about 2 minutes, the crystal inside the tube changes color in the presence of alcohol. For example, yellow to green. The further up the graduated tube, the green color appears, the greater the concentration of alcohol user has and their system. So this is a kind of tool, those who are very frequent drinkers. So the one day, if somebody goes to party and has taken drink, then if he has the option to checking, then he should not drive, he should arrange for his return to home, but some other process to but he should not be on, he or she should not be on wheel. That is what must. Then again, single-use breath analyzer. Use a blow bag to make sure the right volume of deep lung air passes through the tester. Too little air equals a falsely low reading, too much equals a falsely high reading. The blow bag eliminates this issue and helps to give you one of the most accurate disposable breath analyzer reading. This is also available. Somebody wants to, can use. But if you want to use the equipment very rugged and for repeated use, where it can have a many more, not just precautionary, then it has to be those either based of fuel cell based or either IR technology based, infrared technology based. Now here, what can cause breath analyzer false positive or incorrect result? There are a number of factors including breath analyzer. So if calibration has not been done proper, then it will cause a faulty result. One of the most major and important reason that calibration or to get a correct result from instrument and analyzer, we all know it has to be calibrated with the correct protocol and methodologies. again, mouth alcohol contamination due to mouthwash or mouth freshener. What happens many a times, people think that if I take the mouth freshener, then the police will not able to catch it. But one must understand every mouth freshener has alcohol already. So that will not hide, but it will add more to it. So some of the people, young boys or girls, try to do this. So they have to be careful. They will be caught unnecessarily without having consumed beyond the limit. So that is environmental factors such as temperature, humidity, etc. also has an impact. The state of device can cause false positive, like upkeeping of device has not been kept properly. It has been contaminated, mishandled. Then also it will give the other illnesses present in the person being tested, such as diabetic. Some of the other cases are also there where the person, there will be a keto group or OH group in their breath. They may not have consumed alcohol, but they will be there. The person is taking some medication which is having metabolites containing OH functional group. That goes because some medicines have that, or maybe after the breakup of that medicine, when he or she consumes. So if such is the situation, then you should have the information if you are driving, because otherwise unnecessarily you will be caught and you will be in trouble. So one has to know these things when you are behind on the wheel. The novel use of breath analyzer is very interesting as diagnostic tool in medical science. Nowadays, it is being used and is really very surprising to me. The breath analyzer is one clinical practice that has helped doctors to detect specific diseases in patients, like including inflammatory lungs disease, because nowadays doctors analyze very breadth of a patient and try to understand there will be tracer marker for various diseases and try to understand whether in future that person, or maybe at very low level, that person has some illness like chronic obstructive pulmonary disease, asthma, a few of the prostate, bladder, and kidney cancers. In those cases, you get a signature compounds, which you throw the IR analyzer, breath analyzer, one can trace it that and identify those tracer compounds and caution the patient that in future you may have these diseases, and so you should take medical help. So this is, in fact, one of the published literature I found for the breast cancer, one of the research published that they have found a signature of a compound through the breath analysis in the case of very early stage of breast cancer. It was very pleasant surprise to me that it can be a so useful tool for the good keeping of health of the human being. These tests are designed to analyze the composite of exhaled breath, which provides important information about human exposomes. Whatever you expose, so what has caused which kind of compound and whatever, that shows somewhere in your body some minor problem is coming on. So you take attention, do attention to it. That is what. Now we come to, after so these introductory things, we come to the calibration standards are certified reference material, CRM. Here I must mention that I am not defining CRM. As per meteorology, definition of CRM is different, but in the colloquial language, because most of the people who are using this and working there in colloquial language, they call it calibration. So those calibration standards are certified reference material for the breath analyzer, but it could not be only for breath analyzer. CRMs are for many purposes. These are known concentrations of ethanol in a gas or liquid medium that is used to calibrate, used for the calibration of breath analyzers reading. The calibration CRM for breath analyzers can be of following two types: certified aqueous ethanol solutions, These solutions involve a precise concentration of ethanol in water, often prepared in air at a controlled temperature. At a controlled temperature is very important. It is having a certified value with a stated uncertainty, and all quality management system must have been followed. That I have not written down here. Then again, another type is certified compressed gas mixture of ethanol in nitrogen gas. Nitrogen is in inert gas, helium is in inert gas, but then it becomes very costly. Helium is, nitrogen will do the purpose. These mixtures contain a known concentration of ethanol vapor in a carrier gas, such as nitrogen. Breath alcohol simulators are nowadays also available, through which also one can do calibration of the breath alcohol. This method uses a liquid solution of ethanol in water to simulate the alcohol vapor in a person's breath. The breath analyzer is exposed to this simulated breath, and the reading is compared to know the concentration of alcohol in the solution. So these are the two broad type, and the breath alcohol simulator also can use. Suppose if difficult to get the calibration standards, then you can, if someone can have the breath and alcohol simulator, one can use it for this purpose. Very compactly, I have tried to explain the preparation of a certified aqueous methanol solution. Of course, the steps will not be so easy, but I will try to. So flow chart here it is. What you have to do? First, you have to decide what is the concentration of you want to prepare. Then do the theoretical calculation for the mass. Do the theoretical calculation for the mass of ethanol and water. How much water you need, how much water. Take a clean and dry volumetric flask and weigh. Take a clean and dry volumetric flask plus required mass. As you are aware, dry mass, stir it, and then put the alcohol and then take the weight. So certain metrological procedures are required. In a simple way, we are putting it over there. Take a clean and dry volume flask with, then again, the previous one steps I'm just, then required mass of ethanol, then the required mass of water added to it, make it, and take the weight. If you are preparing by weight, if you are preparing by volume, then put it on up to mark. Then once you have put on, mixed it, then homogenize the mixture thoroughly and store the in airtight bottle. Calculate the final concentration, validate, certify the value. Also, calculate the uncertainty, which is very, very important. What is the uncertainty? Before certifying, one has to find out what is the uncertainty associated. So mass, how will you calculate mass of alcohol? W1 will be concentration multiplied by the mass of diluent. So for 500 mg of alcohol is required for 1 liter of water or 1 kg of water, whichever. If you want to make the standard milligram per liter or milligram per kg, both unit applies. One can use any one of that. So just one example I have showed that how much you need for this one. And once you have done, you need to prepare. Here I have just showed this amount for this standard, and slowly you have to prepare all the preparation. What you will do in duplicate, triplicate or duplicate, minimum to duplicate, because sometimes it happens when here you have to take care of evaporation, temperature and humidity very, very stringently and carefully. So the room, laboratory, and that all discipline, and plus cross contamination, dust particle, and all this care one has to take. So do this preparation, duplicate each concentration level, find out the concentration, then stated expanded uncertainty. So this is, I just showed it. This is not actual data. This is, I have prepared these values. This is a fictitious data. Like for the calibration of any range which we are on in the working in the, for our country need, we need to prepare this, and then we need to do the calibration curve using the analyzer and find out the unknown breath alcohol concentration using those calibration curves. Or one single point, if we wish to use, we can use single point calibration also. But better if we use multi-point calibration. 3-point calibration. Now we come to the preparation of certified gas mixture of ethanol in hydrogen and nitrogen gas, sorry. So in this case, again, we need to do the theoretical calculation, how much amount of alcohol we will take, how much amount of nitrogen gas we will. The reagents required in this case is ethanol and hydrogen gas. Hydrogen gas has to be oxygen free. In the previous slide, sorry, in this case, ethanol water has to be for the aqueous organic free water. I missed it, I'm sorry. So organic free water, it has to be in those cases. Here oxygen, because we know the ethanol reacts with oxygen to form acetic acid. So oxygen free as possible, or remove as much possible as nitrogen gas from the nitrogen, which is really, you have to do theoretical calculation that how much is the concentration. First, so if you are preparing in the cylinder, you have to find out, because in the case of gas, safety factors are very important. So what is the maximum capacity up to which you can fill the cylinder? Because once you are preparing, it is so lengthy, and you wish to prepare a good amount so that we can use. The stability is also good for this standard. So we prepare. So what is the maximum pressure up to which we can fill it? So, and how much gas it will consume, how many kg of gas. So first find out that, then calculate the required mass of nitrogen, targeted concentration of CRM says C1. Then one can calculate the required mass of methanol. So mass of methanol, W, can be calculated from the W1, that is weight of nitrogen can be filled in the cylinder within the safety limit, and the concentration. Take care of units properly, because here you have come into what? So you have to take care of units properly. Otherwise, there will be blunder. So whenever we are working, we have to take care proper unit or proper care. And what you have to do, that you have to put the cylinders for the evacuation. In the case of gases, cylinder preparation is very tricky, because if any organic molecule, VOC or anything, it will spoil your standard. So it is needs, the cylinders are needed to be evacuated. Heating at a 70-degree temperature, all the gases are expelled, and this for 24 hours this is run, and the vacuum created over here is 10 to -4 bar. So very, very low vacuum is achieved. Then again, it is purged with the pure nitrogen, and again expelled. This process is repeated a minimum 2 times or 3 times, it is better. That makes your standard better stable, because the stability will be good as nicely you have prepared the cylinder. So in the meantime, you do calculation, you have to start the experiment and start doing the cylinder preparation. And once this process is going on, you need to do some pre-exploratory work. What is the pre-exploratory? Alcohol, purity of alcohol, one has to determine. Sometimes if you don't want to to the purity, then nowadays NMIs are providing ultra pure alcohol certified value. That also where you can mean, because your purpose is not here, because the objective is that we want to prepare the standard. So no need. No, so either the two way, if you have facility and capability, time you can take, you can determine the purity of alcohol. Various analytical techniques are there, so you can use it. This is very common. Or you can take from any NMI. So many NMIs in the world are sending. Nowadays, I think Sigma Eldritch is also Sigma Eldritch or some other chemical companies are sending certified purity, with the certified purity, high purity chemicals. So you can use that also. Once you have done that, then it comes, because in the case of transfer of the gases, you have to transfer it, the syringes. A calibrated gas type syringes are taken, liquid syringes. So what you have to do, you have to practice and see how much amount you have calculated. Here I am just showing one example. Suppose after my calculation, I need 8.7 milligram of alcohol. Now with my syringe, then I transfer that. How much repeated you have to just so that how much error remains and how much. So how you achieve the theoretical value. Every micro level of calibration slowly by pressing it, you see that you achieve that much. As accurately you will achieve that, your targeted mass, your calculated final prepared standard will be very near to it. So this is where you can, if you just put something instead of say 8.7 milligram, say 10 milligram, then your standard will become of different concentration. That may go beyond your measurement range. So what is the measurement target? Your standard should be always 10% higher than the targeted concentration you achieve. This is just thumb rule in chemical analysis. So you have to see in that. Suppose 3-4 ranges of standards you are preparing, then you must have a spacing of the points in the calibration curve. Another very important exploratory work you have to do, this will be once you do and you have the data, then in the lab you can do on repeat. Every time you don't need. Then another very important point is that you have to see whatever amount you have calculated, how much time does it take to evaporate. You are not supposed to boil it. I will tell you why. Because if you boil it fastly, it will evaporate, but you are not supposed to boil it. You have to evaporate it slowly enough to get in the gas mixture. So as suppose at 50 degree, the boiling point of alcohol, if I am not mistaken, 78 degrees centigrade is, I think so. So much below that, so how much time does it take? So 50 seconds or so. When you are transferring in the cylinder and heating, you will need this data during the mixing of these gases. So this pre-exploratory work one has to do before he or she goes for the actual mixing of methanol in alcohol. Actual mixing of methanol in nitrogen. So here I have, so this is not so simple straight. In the cylinder, you have to have an arrangement. All this has to be high pressure filling line. Stainless steel high pressure filling line, not the mild steel or simple steel. These fittings have to be very, very high pressure filling line. And whatever pressure you are working, the safety, it should be like the cylinder which I am showing, it is having filling capacity up to 200 bar, but usually we fill up to 120, sometimes up to 150 also go, well below it. And remember, it is that because these high pressure filling lines are very, very, and it has to be very utmost safety and care. So here is an arrangement. Here arrangement is there, and a nut valve is on this at this point, and which you can open, and by the drop on the from the syringe you can put it here, and it is once you seal it and then you do what? You heat it. Now from the pre-exploratory data, you have information how much time it will take to evaporate. So we don't flow the nitrogen gas. What we do, first we attach the cylinder, attach this system. This is a little bit curved kind of thing with the arrangement, and before putting this, seal all everything and flow the nitrogen gas and bring it up to a certain level of say 70-80 pressure and fill it. But the nitrogen cylinder which you have taken, and that has not to be also empty. Before coming to this stage, this nitrogen cylinder should be filled with whatever decision. Like we have, if we have thought of filling the preparing the cylinder this at 120 bar, and the amount of gas will go in 10-liter cylinder. This one, it will go 1.3 kg, 6 kg something. So at least 1/3 of that weight of nitrogen already you must have filled, and you have taken the correct weight, because in the calculation you will need those things. Understood? So after that, you will put it, open this valve, so all the nitrogen will come out slowly. Once it has a stable nitrogen mixture, then bring it carefully without losing a single drop of it. Pass it into putting the needle inside, not from the outside, because the evaporation is very, and that will cause the mass flow. Bring it inside. For the figuratively, I have shown like this, but ideally it should be brought, the tip should be brought here and it is put in here. And again, immediately, as fast as possible, you seal it. So now this ethyl alcohol is in the environment of nitrogen gas. But gas flow is not there. Remember it. Gas flow is it is a stock. Now slowly evaporate it. Slowly you evaporate it and keep the at least few minutes, more than half a minute or so more, not very long duration, otherwise it will be problem. And why you should not heat it to boiling temperature? If you heat it with very high temperature, it will get deposited, it will evaporate and get. But if you heat it slowly, it evaporates slowly, it gets mixed thoroughly with the nitrogen molecule in it, that it will not get settled. And that is the reason that the it should not get settled into the cylinder and make a monolayer or liquid lying inside, that it has been pre-filled with the nitrogen weight, and the correct weight of that nitrogen is determined before, because you need in calculation all those things. So then it is heated. Once that, after that time, you flow this gas flow and fill it, open this valve and fill it up to pressure on a top pan balance, monitoring how much weight you have calculated, rough weight of that. So once you calculate, achieve that, you seal it and make it rest to overnight, because the gas molecules will be slightly so if make it to equilibrated at room temperature and take the weight next day. Give the overnight time so that all molecules have written. So then the full final weight of the alcohol and nitrogen filled up to say 120 bar if I'm preparing, fill it and then make it. Next day you take weight and do the calculations. You can weigh in top pan balance. I'm just showing the figure. Suppose I have put the mixture, so gas is filled in, so I have to put it. Reference weighing, if you do, that will cancel the buoyancy due to this big large cylinder. So this I'm just showing. You have to take care of buoyancy correction, calculation, and certainty budget and all. So because for the buoyancy correction for the mass for 1.3 kg of gas is 0.2 gram. So in the case of gas, it is considerable. It matters in that. Calculate the actual concentration, homogenize the cylinder after taking weight, validate, do the stability study, do the uncertainty budget calculation, and certify the gas mixture. The density of air, see, density calculation of 1C due to air density is 1.56 milligram per centimeter cube of density. I've just put on some data to have the feeling, because sometimes people, because normal weighing we do in ambient air, so 1C concept for the air is mostly people are not. So these are the informations for that. So once you have prepared the standard, now how will you achieve the traceability? Meteorological traceability of aqueous gas mixture or aqueous or the gas mixture, both cases, those prepared standards will be again given for the laboratory down the line field laboratories, and some of them will be used for international intercomparison. The traceability is achieved because why? Because the mass balance or the mass pieces which you have are linked to 1 kg. Similarly, for country A, for the country B. And so how the measurement of all the countries are linked with each other. Here you can see that similarly for the aqueous solution, also for the gases also you can see, and it is sometimes BIPM also conducts intercomparison, participate in intercomparison, participate in PT programs, so that you are at the know what is the level of your accuracy, sensitivity, accuracy, what is your uncertainty level, how far the light shines in these cases. So this is what it comes. These values are just fictitious. Some ranges I have shown. So this is not actual correct value, and the uncertainty over there is there. So now what are the pros and cons of aqueous and gas mixtures? That we will compare. Liquids are easy to handle, easier to prepare, no need for very sophisticated equipment. Gases needs extra effort and equipment to hold it back. We know all. Requires sophisticated equipment in case of cylinder preparation. You need a very high pressure filling line. Vacuum system you need very, because if you have not prepared the cylinders nicely, if inside VOCs are present, because removing VOC is very, very difficult. Those bulky molecules, it remains adhere on the surface, forms the monolayer, remains on the internal surface. Sometimes some people do the internal surface preparation, but in that process, sometimes it happens, some impurities remain. So I prefer not to put anything, but do the preparation very, very rigorously. And purging gas has also to be used very many times. People want to that gas is to be expelled away, so people use inferior quality of gas for the purging of the cylinder. That makes the standard life of a standard. So when don't we, because we, of course we should not waste money, but sometimes in the lab people think, oh okay, after purging I will explode. But if you put having heavy moisture content or having very high content of VOC, that will spoil the internal laser. So maintain the cylinder nicely prepared very rigorously, that will give more life to your cylinder. Preparation steps are easier here. Here preparation steps are very rigorous. Stability is less in the aqueous case, but here stability is better. If you have prepared the cylinder very nicely, preparation and taken, if you take care of cylinder cross contamination of cylinder, like dedicating the cylinder regulator to it. Don't mix and match the regulator, then it is very good. Or otherwise, whenever you are using any different cylinder, changing it, purge it nicely. Purge it nicely. Otherwise, very common contamination of gases standards are there, that it gets contaminated by the regulators. So either you do approach, if you have enough regulators, you keep it dedicated for that, or otherwise you use purge it nicely and then use it. Shelf life is also around 3 months for the seal bottle. After opening, it is suggested 15 days for or so. The shelf life is around 1 year. Even If you keep handling cross contamination, it can be, if you have a gas left, you can be, but usually for this gases, the alcohol, 1 year life is good enough. Cost is cheaper, but it is costlier there, no doubt. Delicate to handle and needs a special transport. Aqueous standards are delicate to handle because it is glass bottles, and transport has to be a very extreme cold and extreme hot is to be extreme hot is to be. In Germany, they transport early morning so that the evaporation effect is less. In the case of aqueous cylinder, it is very, very it, it does not need delicate handling, but no doubt normal standard transport, normal conditions are extreme cold is to be avoided in this case also, extreme cold. So these are the some pros and cons. Now depends on whatever available, which kind of things are all available. One can opt for it and go for the standards. Both are good. Now we have seen that in the case of measurement, when it is done, calibration is done and all. Now suppose after doing all care and measurement comes out the situation according to 17,025 new decision rules and all. If suppose in the case of measurement in our country, I just want to see how and why it is coming like this, and how important it is that a standard calibration and measurement uncertainty is very, very important. I see upper limit is in our country, upper limit. I have kept the unit same. I did not convert whatever written in the law deliberately, so that it comes to the attention. Now suppose a police measures that the value has come 0.035 milligram per ml. Okay. Now the condition comes here. Uncertainty of this is the case 3 compliance. Now what we should tell whether he has complied the rule or not, whether he should be convicted or not. This is a big decision which is being taken. So every time, no wrong decision should be taken. Always the correct decision should be. The decision rule is focusing on correct rejection. In law, it is important. In our country law, we are on the principle that no innocent person should be punished, convicted, because conviction has not only that, it has a very, very far-reaching impact. So in law, it is important not to punish an innocent person. The decision rule can be set to reduce the chances of this. This is a case of blood alcohol measurement taken from a car driver for drink and driven case. I must underline here, all these are fictitious data. This has been developed. This has been developed to understand the concept. Please don't make it as a rule, because I cannot quote anybody's data, and not from NPL. I have retired from NPL. I am not having any data, and that is NPL property. I have given it to NPL. I am not having. I only from my mind knowledge I am sharing these things. So one must understand that tomorrow no one should say madam has told this. Because these are risky things. So in such situation, what could be done? See whether the person should be convicted, because the person will tell, I am here, isn't it? What is the probability? But you will tell the uncertainty bar. I don't consider uncertainty bar. This type of cases has come in the report. In Germany, one young boy was convicted. He has the knowledge of uncertainty. He questioned, and the court has to leave him. So that is what cases are the. So test result with expanded research. So this situation, see here it is completely failed. Here it is completely out. He should be punished. In the case of this, he should be punished. His quitted. He is beyond the limit. But in this case, and I have taken this case specifically, this case I have left it, one example with that. So here see, the measurement, mass of alcohol in the blood sample as delivered to the laboratory. Measurement has been done. Police has caught him. But here also I wish to mention that I don't have any practical experience. I am in and around my people. So these are just created. What is the procedure and protocol of police of our country? I don't know. So please, if any gap remains, so excuse me for that purpose, because this is just scientific fact and knowledge I'm sharing. Analytical value, mass fraction, the blood sample which has been tested has given the result. Expanded uncertainty value has come like this at the K value 2 at 95%. Standard uncertainty, expanded uncertainty, so divided by 2 will be a standard uncertainty. This uncertainty includes both sampling and analytical result, because sampling also has a considerable amount. I have taken a little bit higher value also here. Now regulation tells upper limit is there. Our country regulate, there is no tolerance, nothing is given. It is told if value is more than this. Now decision rule comes in. Decision rule is the mass fraction above which it can be decided with a confidence level of approximately 99%. That means probability of finding is 0.001. That permitted level has been fully exceeded. Because why this limit decision rule has come? It has come from the philosophy of our rule in the country, judiciary system, that no innocent person should be convicted. So 99.9% chances that we live probability. That now how will you calculate the guard band? Guard band is calculated as K factor of this multiplied by U. K factor of this is 3.10 from the K value of 1 till T value, because this is in one direction, T value, 99% is 3.10. The decision limit will be 0.3, which is here, limited by government, plus 0.093. If you multiply this with the uncertainty, standard uncertainty, you have to multiply. Then the limit, this shifts by this. All the values below this are in the accepted zone as per the philosophy and that concept of that decision rule. And the acceptance that result does not justify a claim that limit has been exceeded and all the values equal to or above are rejected. So if you add, this is the limit. So guard limit is this. Understood? So what becomes the new limit? New limit becomes 0.0393 milliliter. So whatever I have has been measured in this case, measured in this case 0.035. What is the situation now? You will tell this complies, that they have not crossed the limit. The driver, for say Fixisius, has not crossed the limit of drink and drive result. So how the guard band has shifted, the upper limit is this. From the figure I have explained, upper limit is this. So acceptance zones has shifted higher, and now after. So what rule tells? Any value more than 0.0393 milligram per liter, this much, equal to this much or more, will be convicted. Will be convicted, equal to also. So this is the concept over here. So why I put it? Because nowadays many people are putting, of course, in this case, breath analyzer case, but I've thought now this concept of how to apply and how to determine the guard band to find out, take the correct decision. That's why I have put on these things. So this is very interesting due to this, that when so if anybody has got, this is fictitious data, please don't consider. So next time, don't claim to police. This is fictitious data. Actually, when The test will be done. What will be the actual uncertainty? The value will shift into. So it will shift to case, not the one. So whenever the testing is done for one person at one point, this does not become a uniform rule. You please recall, this value is associated with this measurement of expanded uncertainty. This uncertainty can be lower also if very sensitive. Here it is approximately 20%. Taking field sample, very coarse value I took so that it will be visible in the presentation. Suppose if 5% and less is there, then it will become less. So don't consider that I have told it. This is just to explain. So it depends on whatever, how the measurement is done and what is the expanded uncertainty. It depends on, of course, this factor and this K value remains constant. It is the guide on the basis of what is the philosophy of our judiciary system. I hope everybody understands that and the facts are clear. Now, the concluding remarks, there must be availability of calibration standards, CRMs, for the calibration of breath analyzer to all the stakeholders in the country. There has to be technical document for calibration of various types of breath analyzer. The personnel should be properly trained. In nutshell, the laboratory or organization or field lab must follow ISO 17025-17 for its calibration service, and for the standard preparation ISO 17034-2016. That's all. Because that is latest. If you are preparing, doing the calibration service, and okay, this one, if you are preparing the standard, then you must have follow 17016 also, 2016 version. All the calibration certificate must mention the complete established chain of traceability with expanded uncertainty. This will result in correct detection of guilty person. There will be least possible probability of convincing an innocent and guilty being quit fastly. दोनों ही बात गलत है. Both the facts are wrong. When an innocent is proclaimed guilty, it has a very bad impact on that person. It may come to his reputation. He or she may lose his job, her job or livelihood. He or she may lose his or her confidence, self-esteem. In the court cases, he or she may lose the child custody, an important family relation. He or she will have monetary loss also. So no one innocent should be proclaimed to that. So this is very, very important. Maybe it looks very simple, but it has a very, very, very far deeper impact on the person's well-being. Somebody may, if somebody gets falsely convicted, then his moral and esteem will down. It will have bad psychological impact. So that should be avoided. Okay. So this is what I wish to tell in this. Thanks a lot. Hope some rainbow science in knowledge. I could add some knowledge to you. And now the talk is open for discussion. Anything, if anybody wants to ask, can ask me. Hello.
Hello.
Yes, yes sir.
काढून घेते पण ते काम कोणी लोक ताण जरी असंच कपडे टाकायला गाडी घातला का काढून तू नाही अभ्यास राहिला ही तुला नाही वाटते ఇది కలుపుతారు కూడా పాపం.
Hello. I'm not able to hear anyone of you.
Ma'am, please answer your presentation.
Thank all the participants. Thank you very much. We will meet next week with the next topic. Thank you all. Bye. Good day. Thank you.
Good.